how to count atoms. If you guys did the readings yesterday, like it should help you. But let's go through the basics. So I have a molecule here. So there are two parts to this. There's what's called the coefficient. Almost ran out of room there. It's called the coefficient. And then this one right here is what's called the subscript. We have the coefficient and we have the subscript. The subscript meaning submarine, means under, and then script is written. So it's under the written. So this number is under the written portion. That's why it's called a subscript. And then we have the coefficient. So I have some disclaimers that I've been teaching this long enough to know where most students make the problem at. Okay? You can only change the coefficient. We will not get into making or predicting molecules. So in this class, you will only change the coefficient. You do not have the ability to mess with the little numbers. It's beyond your pay grade. You can't do it. Don't do it. If you mess with the little numbers, you'll never get these answers correct. Okay? Do not mess with the little numbers. You can only mess with the coefficient or the number in front. This is the only one you get to touch. Okay? No. Yes. No. Okay? Very clear. Don't mess with the subscript. The second main point for us, unless there is a parentheses, the subscript is only for the atom before it. So what I mean by this is that the subscript that's in front of the O, that is only for the O, for oxygen, not carbon. Okay? It is the subscript is only in front of the O, or oxygen. So that 3 only belongs to the oxygen. It does not belong to carbon. If there is no parentheses, those brackets, it's only that person's. Okay? Don't give it to anyone else. Okay? It's only his. So those are the biggest issues that I see when we do balancing equations. But we're going to write down some rules of things to follow or things you might see and how to deal with them, and then we'll do some examples. Okay? After we know how to count, we can do balancing. So rule number 1. If there is no subscript, it is 1. That's the same for coefficient. Keep leaving that off. If there is no subscript or coefficient, it is 1. I'll show you why. It just looks really messy when you start adding ones in. So, for example, if I was to do CH2O, what this is really equal to is 1C1H2O1. Meaning, if there is no 1 there, so there's no 1 in front of my C, I'm assuming it's 1. It looks really messy when you start writing out the ones. If it was 0, it wouldn't be there. So if you have just a blank space, it's indicative of 1. It's indicative of 1. You don't have to write it, and you won't see it written. Rule 2. There's only 3 rules, if that makes you happy. When there is a parenthesis around a compound, the subscript belongs to all atoms in the parentheses. So when there is a parentheses, the subscript belongs to everyone inside. It's very much like math when you have like 2 parentheses 5x in parentheses. That 2 belongs both to the 5 and the x. That made no sense, ignore it. I'm going to show you the example. So in my example, NO3 is in parentheses. This 2 right here belongs both to the N and to the O. And much like math, if something's in a parentheses, you multiply by the outside. So if it's 2 parentheses 5x, you're doing 2 times by 5. So 2 times by the 1 on the N and 2 times by the 3 on the O. So this guy really means this. So that 2 just gets distributed to everyone in the parentheses. And I actually do that first. So no matter what I'm doing, I always do that first. It's just, if I see a parentheses, it's my first step, just like in math. Rule 3. Now, disclaimer, there is a 4th rule for us, but it deals with polyatomic ions, which is above our pay grade, so I'm ignoring it. But just in case you ever keep going and you're like, Miss Ryan said that's the end of balancing, and someone keeps going, like, there is another step. We're just stopping here because of time constraints. So rule 3, which is the hardest rule, coefficients get multiplied by each of the elements subscripts. So coefficients get multiplied by each of the elements subscripts, sorry. So the big number gets multiplied by the little number. There's a lot of multiplying right now. Okay. Big number gets multiplied by the little number. Okay. So what this looks like is you could have 2CO2 and the coefficient will get multiplied by each of the subscripts. Meaning there is technically, wrong color. With this, there is 2 C's. Because 2 times by 1 is 2. The O's, there's 2 times by 2. So there's a total of 4 O's. So big number times small number. The last step to this would look like this. This is the biggest compound you could get to here in terms of different things that can be thrown at you when it comes to counting. When you have this, I find that the easiest thing to do first is go ahead and get rid of your parentheses. Go ahead and get rid of your parentheses. So how we get rid of the parentheses is we'll take this 2 on the outside and we'll go ahead and distribute it, just like in math. We'll distribute it. So now we have 2CA, and then I'll take my 2 outside the parentheses and multiply it by 1. So now I have 2 N's, 2 times by 3, so now I have 6 O's. Okay. Now it looks a little bit easier. Now it looks like the one above it to give away your coefficient. So now we'll take the 2 on the coefficient and we'll spread it out between everyone. So 2 times by 1, I will have 2 CAs. 2 times by 2, I'll now have 4 N's. 2 times by 6, I'll now have 12 O's. Again, that last one's the bigger one, like it's going to be a little bit more difficult. Yeah, it's going to be a little bit more difficult. Okay, I want to do a few example problems at this point just to let you guys see them, try them, so that you're not just writing stuff down and not connecting with it. I'm going to take my papers down. Again, if you're a little bit slower of a writer, I will always put these back up at the end, or you can always come up and ask for them. I have a lot of people ask me for photos of my notes, and then they'll copy them later on in the day. Okay. Okay, so the first one, CaCl2. I want you to try and tell me how many CAs you have and how many Cls you have. Do you need something?
Yeah, let me put my paper.
Logan, can you pick up your paper then? Or pick up his paper, please? Thank you. Okay, CaCl. How many do you have? Cadence, how many CAs do I have? Nope. 1. Okay. Peyton, how many CLs do I have? 2. I have 2. So again, remember, if there is nothing there, it's a 1. So 1 times by 1 gives me 1 CA. 1 times by 2 gives me 2 CLs. Okay, let's try another one. CaSO3, 2. So how many CAs, how many S's, and how many O's do you think we have? Okay. Guadalupe, how many CAs do you think we have? How many CAs do you think we have? 1. Perfect. Valerie, how many S's do you think we have? 2. Yep. Yeah, distribute that 2. So we have 2 S's. And then, Mal, how many O's do you think we have? Times by 2? 6. Perfect. Next one. 3 and a 2. Oh, that's hard to see probably. 3 and a 2. CO3. How many NAs? How many C's? And how many O's? Okay, remember, distribute that coefficient, that big number, and multiply it by all the little numbers. Okay. Jacob, how many NAs do you think we have? Times by 3. We have 6. How many C's do we have, Lewis? 3. So 3 times by 1 is going to give me 3. Okay, and then I'll see how many O's do you think we have? So 3.
Oh, it's
9. Very good. 9. Good job, guys. Okay, one more. Up the ante, just a little bit harder. Okay, so okay. Zoe, how many irons or FEs do you think we have? We do have 2. Now, when you get to parentheses, I would suggest you pause and you go ahead and distribute. So I'm going to distribute there. So 2 times by 1, 3 times by 2. So this is really into 06. With that in mind, Colin, how many N's do we have?
5.
2 times by 2 is
4.
4. Perfect. Great job. And then, Miss Al, what about our O's? We have 12. 2 times by 6 is going to give us 12.